Assalamualaikum. How are you? Fine. You will be fine. Okay. Today we are going to discuss about the topic. This topic is from AS Physics 9702 is the code, and the topic is actually related to the physical quantities and measurements. And in that topic, we are going to discuss about the nature of physical quantities like vectors. Okay, so vectors are basically those physical quantities which need magnitude, unit, and direction. And their examples are, let's say, I have written some examples over here: displacement, then we have velocity, then we have force, then acceleration, and so on. So many others. Then when we are going to handle a vector, or when we are talking about the vectors, there are two main aspects. One, how to represent a vector. A vector is represented by two things. One, um, with the help of an arrow. That arrow has two aspects. One is its length, and the second one is its direction. The length of the arrow shows the magnitude, and direction, definitely it shows the direction of that. For example, here if I have a vector of 3 centimeter, then its length is 3 centimeter or 3 meter. And if I want to show a vector with length 5 centimeter, it shows something larger, right? In different books, it is represented by bold letters, any letter with arrowheads. So this is what how to represent a vector. Now the next aspect is how to handle the vectors. When we are going to handle the vectors, there are two main classifications over there. One, resolving the vector into its horizontal and vertical components, mutually perpendicular components. And second one is to combine the vectors, right? So first I will talk about the resolving. So resolving means, if we have any vector a over here, then we can have its mutually perpendicular components, like I have shown these components over here. One component is ax and the second one is ay. Basically, ax is its component of a along x-axis, and ay is the component of a along y-axis. Very important thing, that y component is the component in front of your theta, angle theta. In general triangular concepts, if I say this is base, this is hypotenuse, and this is my perpendicular. So when we talk about these three, this base is also named as adjacent, this perpendicular is named as opposite, and then hypotenuse is hypotenuse. So if I say that sine theta according to trigonometric ratios, that is perpendicular divided by base, or opposite divided by uh, sorry, sine is perpendicular divided by hypotenuse, or opposite divided by hypotenuse. That's why if I consider this over here, ay is your perpendicular, a is your hypotenuse, ax is your base. So ay is equals to a sine theta, right? Because sine theta over here is equals to ay divided by a. From here I get this relation. Similarly, cos theta is equals to ax divided by a, which shows that ax is equals to a cos theta. Now, it's not mandatory that all these vectors which are to be resolved, they are at x-axis. Their reference is x-axis. Sometimes they are inclined at certain angles. That's why this is called inclined plane resolving. So here I'm going to resolve the vectors, resolve the weight of an object, which is basically mentioned over here. It is mg, and here this is resolved into two components. This component is mg sine theta, and this component is its mg cos theta. Similarly, if I have a simple pendulum at rest or in equilibrium position, its mass is weight is mg, and the force which is over here that is tension force. And if this is placed, this was its equilibrium position O, now this is an extreme position A over here. And if this extreme position is considered with respect to the forces are, one is the weight is perpendicularly downward, and then you have two forces. Sorry, here we have another force, tension. This is in this direction. Now I have resolved the weight into two components. One component is along y-axis, I mean the mutual perpendicular component, and then the second one is along x-axis. So overall, this is basically your sine component, this is your cos component. And if I say that now we are going to have to resolve these all, then this lower one is your mg sine theta, the upper one is your mg cos theta, and so on. So it is your mg sine theta, and that is mg cos theta. So this is all about resolving of the vectors. There are some other examples as well, but till now we will discuss these examples. In my next lecture, inshallah, we will discuss about the combination of the vectors and how to combine the vectors from their independent vector or independent components. Right now, I have shown this all at one screen. I hope that this all is summarized over here and you will enjoy this lesson. Thank you.